Mysterious Mountains, a Transatlantic Puzzle. For almost 2,000 years, scientists have been trying to unravel the mystery of the Earth's past to explain geologic phenomena. Scientists have found mountain ranges with the same rock formations located thousands of kilometers apart. They've found the same types of dinosaur fossils on continents separated by oceans, and they've observed continents with edges that seem to fit together like the pieces of a jigsaw puzzle. But what does this all mean, and what can it tell us about the Earth's past? To answer these questions, let's take a closer look at one case study, the Appalachian Mountains in the United States and the Grampian Mountains in Scotland in the United Kingdom. The Appalachian Mountains are around 3,200 kilometers or 2,000 miles long. They start on the island of Newfoundland in Canada and stretch all the way down to central Alabama in the southern United States. You can find granite, an intrusive igneous rock, and limestone, a marine sedimentary rock, all along the chain. On the other side of the Atlantic Ocean, in the United Kingdom's tallest peak, Ben Nevis, can be found in the Grampian Mountains. This mountain range shares many similarities with the Appalachian Mountains. Like the Appalachians, the Grampian Mountains run in a northeast to southwest direction. They also contain granite and limestone. In his 1908 lecture at Columbia University in New York, German geologist Albrecht Pank, 1858 to 1945, noted, "These two sides of the Atlantic have the same structural features. There is an astonishing symmetry. One seems to continue the other. Geologists have also found similar folded rock patterns in the Anti-Atlas Mountains of Morocco in North Africa." Geologic research carried out in the early 20th century identified that these mountain ranges are of the same age. Relative dating, a method used to estimate rock age, suggests that the limestone sediments in the three mountain ranges were deposited at the same time. But how could this be? Another mystery is that isolated continents share index fossils. Index fossils are fossilized evidence of plants or animals that are characteristic of a particular geologic time and geographic area. For example, the dog-sized mammal-like reptile Cynognathus that lived around 240 million years ago. The remains of this reptile have been found in both southern Africa and South America. Cynognathus was a land-based reptile, so it is unlikely that it was able to swim across oceans. So how did its fossilized remains show up on these two continents? Fossilized plant remains have also been found on different continents. Glossopteris, an ancient woody shrub, is one example. Archaeologists have uncovered the fossil in Antarctica, Australia, and India. But how could this plant have traveled across oceans? The same shores? The shorelines of many land masses match. This fit is more obvious when looking at a map of the seafloor. The edges of the land and the edges of offshore continental shelves seem to go together. Look at the map on page 94. You can easily imagine South America and Africa joining together. The coastlines of each continent seem to fit together like the pieces of a jigsaw puzzle. So what do you think? Are these mysteries a coincidence Or are they evidence of something else?